In this video, we're looking at polynomial functions. So a polynomial function has several x's with multiple different powers. And when we write these polynomials down, the highest power of x always goes first. So what I mean by that is if I write an example of a polynomial here, let's say px, we could have something such as 5x to the power of 6 plus 2x to the power of 5 plus 3x to the power of 3 minus 2x squared plus 2. Okay, that there is a polynomial. There's several powers of x's in there and they're all spread out. So we're going to cover some of the terminology when you're dealing with polynomials. And the first thing is what the degree of the polynomial is, and this is just the highest power. So if we use that example I wrote at the top, the highest power for that example I wrote in red at the top of your screen would be 6. So that has a degree of 6. Now, the coefficients are the numbers in front of each x. So if I said, tell me the coefficient of x to the power of 5, you'd be looking at the number out the front of the x to the power of 5, which is 2. So that has a coefficient of 2. Now, the leading term is always the term with the highest power that's coming out the front. And in this case, the leading term would be 5x to the power of 6. Then we have the constant term, and this is always the number at the very end that has no x's next to it. So in this case, it's 2. It's also your y-intercept. Now, a monic polynomial is if the coefficient out the front is 1. So in our example, this is not a monic one because the coefficient out the front was 5. So an example could be something like x squared plus 2x plus 1. That would be a monic parabola or a monic polynomial. It's where the number out the front of that x squared there is 1. So here we're going to do some more examples. We're going to write the degree, constant, leading term, and coefficient of x to the power of 4 for the following polynomial. All right. So remember, for the degree, it's the highest power. So this has a degree of 5. Our constant is the number that is not connected to any x's. So in this case, it's 4. The coefficient of x to the power of 4 is whatever number's out the front. In this case, it's -3. And then that's it for that one. You can get a range of different questions there, but just race through, answer them. Fairly simple, those ones. It's just understanding all the different terminology. All right, so we're looking at graphing polynomials now, and there's 4 main steps. The first one is to factorize, and sometimes you'll see it as finding the product of its factors. If possible, sometimes it's not, but if it is, you should factorize. The next thing you want to do is find any x and y intercepts because they'll help you sketch it and plot it. Number 3 is if you've found multiple x intercepts, you want to see what's happening in between those and what's happening in terms of the graph. Is it above or below the x-axis? Now, if you've done any cubic sketching before, it's very similar to that. And lastly, number 4 is to sketch the actual curve. So here we have a polynomial, which we're going to try and sketch. So the first thing we're going to do was number 1, and we're going to try and factorize it if possible. So px equals x to the power of 4 plus 3x3 plus 2x squared. And you look for any common factors. That's the first thing you always do with these. Look for common factors. And in this case, x squared was our common factor, so that can be brought out the front. Like that. And then you look, can we factorize that quadratic down? And we can, so we're left with x squared, x plus 1, x plus 2. All right, so now we're going to number 2. And we want to find our x-intercepts. And we want our y-intercepts. Okay, so our x-intercepts are just going to be, well, what is this, or what do our x's need to be? So if I write this out down here, we have x squared 0 equals x squared, because remember x-intercept is when y equals 0. We want this x will need to be 0, because anything times 0 is 0. This x is going to be -1, and this x here is going to be -2. Okay. Our y-intercepts, remember it's the constant. So if I go back to the very original one that we had px equals x to the power of 4 plus 3x cubed plus 2x squared. There was no constant at the end here, so our y-intercept is 0. Okay, so we found our x-intercepts, we found our y-intercepts. Step 3 was to identify what's happening between these. So we need to test our values between the intercepts, between the x-intercepts. Okay, so what I like to do when you get to this point is I like to draw a grid, and then I want to put on all my x-intercepts. So we know there's one here at 0. We know there's one here, that's at -1. And then there's one here at -2. Okay, so now what I want to do is pick some points between all those there. So I know I could pick one out here at like -3. I could pick one in between, -1.5, and I could pick one in here at -0.5, and then over here 1. So I've got a range of values I need to test now. So when x equals -3, y is going to equal -3 to the power of 4 plus 3 times -3 cubed plus 2 times -3 squared. Put that in the calculator and you get 18, which is going to be above. All right, so we're going to keep doing that. I'm not going to put in every single one. I'm just going to write what it comes out as. This came out as -0.5625, and that's below. Then we have x equals -0.5, and y equaled 0.1875, and that's above. And then last we had x equals 1, and y equals 6, which was also above. Okay, so let's zoom out a bit. So what I've got, I'm can sketch this now. So what it's saying is, when it's left of -2, it's above. Then when it's between -2 and -1, we're going to be below the x-axis. Then we go back to -1 and 0, above, and then we stay above. So I'll show you what that looks like. So essentially what's happening is we're coming, not like that, that's a terrible start to a curve, down here. We're below the x-axis between those points, we come up, we go back down, we hit here, and then we go back up again. Okay, so terrible curve, it's hard to sketch on these, but you see what I'm trying to say. You could do it a lot smoother on a piece of paper, but essentially you're using the information we just found about where it is between these points to do our sketch. So that would be the sketch of px equals x to the power of 4 plus 3x cubed plus 2x squared.